All right, go and take your handout out. They're your homework from the last lesson as we finish up our review for your pre-calculus exam in our next lesson, lesson 44. We reviewed right triangles at the end of our last lesson. Remember Pythagorean theorem, if you know two sides to get the third side. If you know two of the angles, of course a right angle being one of them, but if you know two of the angles, remember the two acute angles complementary. And then to find whatever you don't have two of. You're missing a couple of angles or you're missing two of your sides. You would use trig functions, trig ratios. And you start take what's given, say, all right, what do I have related to the given angle? Or what two sides am I given in relation to the angle I'm finding? And use arc functions to find angles and stuff like that. We also reviewed over the line diagrams on the unit circle, which line is which. Make sure you review over that tonight as well. Everything else pretty much from the exam we'll go over now, and if we have time, we may double back to those things, or as our esteemed White House Press Secretary says, circle back to those things. Let's go ahead and take a look at the review sheet, getting off politics here. We're given that the cotangent of alpha is negative 15 to 8. And we're given that the secant of alpha is less than 0. We're asked to find the other trig ratios. So the sine of alpha, the cosine of alpha, the tangent of alpha. We already know the cotangent. The secant of alpha and the cosecant of alpha. One of the first things we'll want to do is determine the quadrant, only because if you don't, you'll forget about it. So I would start with the quadrant here. ASTC. If cotangent is negative, class, that means we are in either quadrant.
First or second, or first, second, or
second or fourth, because all are positive here, so it can't be that, and tangent's positive here, so it can't be that. But we're also told that secant's less than 0, meaning secant is negative, so where would secant be negative?
2 or 3.
2 or 3, because secant goes with cosine, so all, of course, positive, and then cosine positive. That means clearly we're in quadrant 2, where only the sine and cosecant are positive. Everybody else is going to end up being negative. We could go ahead and get one of these ratios just like that. The tangent, of course, is going to be 8 to 15. But to find the other trig ratios, we're missing something, right? Cotangent's what over what? Adjacent over opposite. So that means we don't know yet the hypotenuse, but you can find the hypotenuse using the Pythagorean theorem. You'll find it to be 17. Once you've got that, we can go from there. Sine is what over what? Opposite over hypotenuse, so 8 over 17, I've already taken care of the positive. Cosine is what over what? Adjacent over hypotenuse, so we'll have 15 over 17, we've already taken care of the negative. Tangent's already good. Secant, we're just going to flip the cosine because it's hypotenuse over adjacent. And cosecant, we're just going to flip the, since it's hypotenuse over opposite. And there are our answers. Questions on this. You will have one like this on the exam. Obviously not this exact problem, but one similar to this. Questions?
Hey, this is literally the exam written into it.
No, I don't do that. All right. For the next one, it says find the exact values of the sine of 210 and some other ones, but we'll just take these one at a time. Whenever you're finding exact values, we realize, well, this is where we'll use either the unit circle or our triangles. But first we need to figure out what quadrant are we in.
3.
Quadrant 3, reference angle. 30, because remember you're always measuring from the horizontal. So in quadrant 2, how far above 180? Quadrant 3, how far below 180? Quadrant 4, how far below 360, or how close to 360? So what is the sine of 30? 1/2. ASTC, though, in quadrant 3, sine is, so we get negative 1/2. Okay. Again, you could use your unit circle, you could use the 30, 60, 90 triangle. What about the secant of 315? Again, start with the quadrant, and then the reference angle.
45.
And then what is the secant of 45?
Square root of 2.
Square root of 2, and in quadrant 4, secant is?
Positive.
So you get positive square root of 2. Cotangent, 180. What's the reference, or what quadrant?
Usually 2 or 3.
2 or 3, we generally say 2, reference angle. 0, because how far is it from 180? It's 0 away from itself, right? So the cotangent of 0, here's where unit circle is really helpful. So remember, on the unit circle, how does the cotangent line get drawn?
From the top.
Across the top, right? Straight out. So at a 0 degree angle, what's the length of the cotangent line? Undefined. So We don't need to worry about positive or negative undefined, which is good because quadrant 3 would be positive, quadrant 2 would be negative, but undefined is neither positive nor negative, so we just say undefined for cotangent of 180 degrees. Or you could do the 0, 90, 90 triangle, get the same answer, 1 over 0, which is undefined. Questions on that one? Read the cosecant of 4 pi over 3. Anytime we see denominator 3, we know our reference angle is going to be 60. We just have to figure out what quadrant we're in. Quadrant 3, it's a little bigger than a whole pi, right? 3/3 would be a pi, which would be 180. It's a little bigger than that, so it pushes it down to the third quadrant. The cosecant of 60.
Negative square root of 3. Positive?
You're right about the negative. Quadrant 3 cosecant is negative, but what is the cosecant of 60?
Square root of 3. I'm just guessing.
What's cosecant? What over what?
Uh,
Hypotenuse over opposite. So as you look at your 30, 60, 90, here's your 60. Opposite square root of 3, hypotenuse 2, adjacent 1.
2 times square root of 3 over 3.
2 times the square root of 3 over 3. And again, this is where it's helpful to have that unit circle memorized, because for a 60-degree angle, you see that the cotangent line is your square root of 3 over 3. This is going to be double that, 2 square root of 3 over 3. And so again, knowing the unit circle takes the triangles out of the picture, which is nice for some of us. You don't have to remember what over what, though by now you should know that anyway. All right, cosine of 5 pi over 6. Anytime you see denominator 6, reference angle? 30. What quadrant? 2. It's a little smaller than a pi, not by much, right? 6/6 here, 5/6 pretty close. Cosine of 30.
Square root of 3.
Square root of 3 over 2. And in quadrant 2, cosines ASTC?
Negative.
Negative. Remember, cosine's quadrant 4, ASTC, that's the cosine right there. Cosecant positive with the sign, it's reciprocal. We have the tangent of 3 pi over 2. Anytime we have denominator 2, we know our reference angle is
45.
90. Careful, denominator 4 is 45. Denominator 2 is 90. And a quadrant? 3 or 4, we usually say 3. Tangent of 90.
0. Undefined.
Undefined. Remember, a 90-degree angle like this is never going to meet up with the tangent line. Undefined. Again, that's where I love the unit circle, because it's quicker than getting the 1 over 0. Helps us to picture the undefined. Of course, quadrant 3, well, it doesn't really matter, right? Quadrant 3 tangent is positive, quadrant 4 tangent is negative, but it's undefined, so there's neither positive nor negative. Again, nothing wrong with triangles. I prefer unit circle, but either one works. Questions on number 2. You will have several exact values to find using your special triangles. Make sure we don't get the 2 and the square root of 3 mixed up. 2 is the hypotenuse. Hypotenuse. If you need to mispronounce it, help you remember hypotenuse. Anyway, number 3. 250 degrees. How many radians? How do we convert degrees to radians? Yes, pi over 180, because you're trying to introduce the pi into the problem, and you're trying to get the degrees to cancel out, which means you have to have degrees on the bottom, hence the pi over the 180 degrees. And so you put your 250 degrees over 1 times your pi over 180 degrees. In addition to canceling off the degree symbol, I'll also cancel off the zeros. And can I reduce 25 and 18?
Yeah.
No. So we'll leave our answer as
25 over 8.
25 pi over 18. Do we have that? All right. Look at the next one. We had 7 pi over 8. And we're trying to find that in terms of degrees. How do we convert radians to degrees? 180 over pi, because we're trying to cancel the pi away. And we want the degrees. So pi's cancel. I can do a little canceling, I guess, with the 8 and 180. Does 8 cancel cleanly with 180? I can at least take a 2 out, right?
4 and 90.
4 and 90. I guess I could take another 2 out to get 2 and 45. That's, I guess, as far as I can go. So we'll do 7 times 45?
315.
And then divide that by 2. 157.5 or 157 and a half degrees would work as well. Or, if you really wanted to be a nerd, 157 degrees, 30 minutes.
Have you ever had someone actually do that on a quiz or something?
No, but I keep waiting for someone to do it. So I keep throwing it out there just in case someone will. All right, Jamie, I have faith in you.
That's a bonus?
No bonus.
Write this in seconds and minutes.
Questions on this? All right, you need to be able to convert degrees radians back and forth on the exam. Number 4 is to rewrite the tangent of 290 degrees as the same function of a positive acute angle. This is kind of like what we were just doing a little bit ago with all those special angles and exact values. The only difference is we don't actually find an answer. We just leave it in terms of the reference angle. So like we did with all of those, let's start with the quadrant.
Reference angle 60.
And the reference angle is,
60.
careful,
70.
70 degrees. So we rewrite it as the tangent of 70. Now again, if this were a special angle, normally we say, well, let's take the tangent of 70, but we don't know, so we'll leave tangent of 70. And quadrant 4 ASTC, negative tangent 70. Are we good to go on this one? Look at the next one, we have the cosecant of 140 degrees. Same thing, start with the quadrant, the reference angle. So we can write this as the cosecant of 40, but ASTC. Positive, it is positive. Quadrant 2 cosecant, remember, goes with sine. But on number 5, it says to rewrite as the cofunction. So we do start everything we just did, same function, but then we've got to change it up and go to the cofunction. When we do, what do we do with the SIGN?
Keep it.
Keep it. But cosecant changes to secant. And then 40 degrees changes to 50 degrees because you want the complementary angle, the co-angle. Do we get positive secant 50 degrees? You'll have problems like those two on the exam as well. What?
How many will we have?
You'll find out.
We're trying to calculate how many questions on this.
Lots. All right, questions on this. Lots more than the first test. All right.
So we have like 60, 70 questions.
Oh, you never know. All right, the next one we had f of x is equal, I guess you'll find out tomorrow. F of x equals 2x squared plus 5, and we were finding f of negative 1. Again, all you have to do, class, is plug in the, for the x. Then follow order of operations. Square it to get, then multiply by 2, then add 5, and we're done. Then we get 7 for f of negative 1. What do we get for f of 4, class?
37.
So you got 37, right? Because 4 squared 16 times 2, 32 plus 5, 37. What about f of m minus 3? Well, you don't do anything different. Instead of an x, you now have an m minus 3 that has to be squared. But still follow order of operations. So start by squaring to get 2 times,
M
Square
squared
minus 6m plus 9.
and then multiply the, to get,
2 squared minus 12m plus 18 plus
and then add the 5 to get,
23.
and there's our answer. 2m squared minus 12m plus 23. How many have that answer? Number 6.
Had someone like put it into like, or like, what's it called, use, not the foil. Like put it in foil form. Have you ever had someone put that in like foil form on like a quiz or exam?
You mean like try to factor this?
Yeah,
It wouldn't factor.
it wouldn't.
Well, 23 is prime, so I mean you can do 1 and 23, but there's no way you're getting that negative 12, even with the 2 to help you, so.
You're right, but I'm sure.
Yeah. Alright, let's do this next one. G of m is equal to m squared minus 2m minus 1, and we want a g of negative 3. And again, that means we're going to have to plug the negative 3 everywhere we see the m, which is here and here. So there's 2 places the negative 3 goes in. So we're going to start by squaring the negative 3, then multiplying negative 2 times negative 3, and then subtracting 1 to get 14. How many had 14 for g of negative 3? All right, then we had g of a plus 2, which means a plus 2 goes there, a plus 2 goes there. So we're going to have the a plus 2 squared minus 2 times a plus 2, and then minus the 1 when we square the a plus 2.
A plus 4 plus 2.
A squared plus 4a plus 4.
Yeah.
And then when we distribute the negative 2,
Negative 2, negative 4, negative 1.
of course we can cancel the 4 and negative 4 to end up with an answer of
A
squared plus 2a minus 1.
Plus 1. Or minus 1.
and there's our answer. How many had this for g of a plus 2? Questions on that? Any questions on the first side of the pre-cal review sheet? Going once on questions. Actually, I just turn the whole thing over, that'd be easier. Going twice on questions. Gone on questions. All
That's what it
right,
took
next
like
page.
2 hours to do.
Didn't take me 2 hours.
It better not take 2 hours because you only have 50 minutes. That's if we start right when the bell rings. We usually talk for a little bit.
Yeah, talking about football, Carson Wentz, how bad he's doing, Marlon Mack. Philip Dorsett.
Georgia losing to Alabama.
All right,
Hilton,
Georgia
Steve
losing to Alabama.
Yeah, when.
Oh, later, yeah.
Hot dog.
We gotta wait till the SEC championship for that. All right, so let's do f of x is equal to 3x plus x squared, and we were determining whether it's even, odd, or neither. To determine whether a function's even or odd or nothing at all, we need to find f of negative x, which means everywhere I see an x, I gotta plug in a negative x. I would show this step instead of trying to do it in your head. Then we can say, well, 3 times negative x,
3 negative x. Or negative 3 x.
Negative 3x.
and negative x when you square it.
Positive x squared.
So plus a positive x squared is just plus x squared.
Neither.
And then we're gonna compare. Are they exactly the same?
No.
No.
Then it's not even. Are they exact opposites?
No.
Then it's not odd. So my answer is
Neither.
neither.
That's fine.
Is it, do you pronounce it neither or neither?
Either way. Actually, I pick either one. All right.
Okay.
What do you do?
All right. F of x equals x cubed negative 7 depends on the
Did I
mood.
not get that?
It's okay. We need to start by finding f of negative x. At least Ethan thought it was funny. New favorite student. Thank you. All right, so we're going to cube the negative x. You laughed too. You just didn't laugh loud enough, Jamie. No favorite student. All right. That wasn't a joke.
Didn't hear it. See me after class.
All right, so the negative x when we cube it, class gives
Negative x cubed.
negative x cubed. And of course, the negative 7 is along for the ride. Then we're going to compare. Are they exactly the same?
No.
Not even. Are they exactly the opposite?
No.
They're not odd, so
Neither.
neither. All right, let's take a look at the next one. We've got f of x is equal to 3x squared positive 2. We need to find
If negative.
f of negative x, which is going to give us 3 times negative x squared plus 2. Of course, when we square the negative x squared, so that gives us 3x squared plus 2. Are they exactly the same?
Even.
Yes, then it is an even function. No examples of odd on this one, just because. All right, questions on that?
Mr. Nasty was feeling cheeky, so he didn't put any odds on that.
I know, just to mix you up. All right, number 9, rewriting as an interval. How would I write 5 is greater than or equal, or x is greater than or equal to 5, Chris?
Parentheses,
No.
negative infinity, comma, for 5, bracket.
So these are all numbers 5, and then it just goes down, 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 smaller and smaller and smaller. But look at the problem, it says x is greater than 5.
So it's gonna be, brackets, 5, comma, infinity, parentheses.
There we go. Look at the next one. Negative 3 is less than x is less than or equal to 2. Quentin.
Parentheses negative 3. Comma 2 bracket.
Very good. How many have this answer? On the next one, 7 is less than or equal to x is less than or equal to 9. Jamie.
Bracket 7, comma 9, bracket.
Not a whole lot of options included there. Well, I mean, you can include all the weird decimals and stuff, I guess so. And then x is less than 8. Ethan.
Parentheses negative infinity comma 8 parentheses.
There we go. Because x is smaller than the 8. Not including the 8. Questions on rewriting as intervals. Sine and cosine. Which one is even, class? Cosine. Which one's odd? Sine. What's the domain of sine and cosine? What's the range of sine and cosine?
Negative 1 to 1.
Negative 1 to 1. Questions on the handout.
Is the brackets negative 1?
Yes, yeah, okay, so good question. It's all real numbers for the domain, or you could say in parentheses, negative infinity to infinity. The range is in brackets, negative 1 to 1, because it does include the negative 1 in the 1. Good question. All right, any other questions on that? All right, graphing is the last concept on the exam. This is what we've been working on most recently, so go and get out some graph paper. You will not need graph paper for the exam. Graph print is already on the exam for you.
Sure.
How do you do that? All word.
You'll find out.
I won't find out.
All right.
Summer school computer apps.
Is there summer school computer apps, he
Yeah.
says?
Yeah.
No.
Not for a grade.
No, that's not even a class on YouTube. I don't know, I thought about it. I thought about like, can I record it to YouTube? That's just so hard.
Screen recorded to YouTube.
Because I could do like a Zoom.
You
If I use Zoom, I could record my own screen, but a lot of what I do, I stand up and teach off the whiteboard as well, showing this, that, and the other. And there's
Side
so
by
much
side.
of it too is going around student by student, instructing and guiding. I think that one just needs a hands-on instructor. If you can't have a hands-on instructor, I wouldn't bother with
As
it.
well as you have to be on Word and watching the video at the same time. Like,
Yeah, you have to watch on your phone or something while working on the computer. It's just hard. So yeah, I figured, yeah, not worth it. All right, so let's go ahead and graph this function of x. And -2 plus the sine of 4/3 x. And let's talk our way through this. I always like to start by looking at the main function. Okay, what key points are we going to be looking for here? Quentin?
0, 1, 0, -1, 0.
Okay, that's where I like to begin, is with the key points from the curve itself. Then I try to see, well, what messes it up? And I usually like to start by looking for amplitude or inversion changes. Is this curve inverted, class?
No.
No. What's the amplitude of the curve, class?
-2.
1. There's an understood 1 right here. That's your amplitude. So no amplitude changes, the normal 1 that we usually have, no inversion. It's going to be all normal. So what are the other changes? Well, I see this -2. What does that do?
moves it up 2.
Vertical, so.
I mean, it moves it down 2.
I'm going to move the whole curve down to. That's important to know because when I set up my graph grid, I'm going to need to give myself room to go down. Does that make sense? So I might start with a high x-axis, so my x prime axis has room to come. Does that make sense? That said, since the graph isn't stretched at all, right, it's just going up a little, down a little, I don't need too much space at least. There's another number up here that's messing with stuff. What's this other number?
That's your horizontal.
Ooh, careful. What is the 4/3?
Or horizontal, what?
That'd be if it said x plus or x minus 4/3.
That's vertical, no, friction, or it's, yeah, where it will go, like.
So there's my vertical shift.
Yep.
There's my inversion, whether or not I do. Obviously I'm not. There's my amplitude.
The period change.
There's my key points. At the end would be my horizontal shift, but I don't have any horizontal shift. This is the period change. Now, the period is at 4/3. What's the period, class?
2 pi over 4/3.
2 pi over 4/3. Okay, but it tells me I'm going to get 4/3 of the curve in by the time I get to 2 pi. All right, so what's the actual period?
3 pi over 2. 8 pi over.
Okay, we multiply by the reciprocal, 3/4, and then the 4 and the 2 cancel, get 1 and 2, hence the 3 pi over 2. All right, so I've analyzed all the weirdness that's going on, and that's one of the things you'll want to do is off to the side, analyze the weirdness. So I've got my f of x axis. Don't forget the arrowheads at the ends, of course. Don't forget the f of x label. Don't want to lose points for that. I'm going to set my x prime axis, or x axis, just a little high, not super high. And of course, it's on the actual x-axis that we're going to label our values, like pi over 2, pi, 3 pi over 2, and 2 pi. You're not going to label those on translated axes. And of course, our units 1, 2, 3, -1, -2, -3, -4, -5. So when it comes time to shift down to, again, my suggestion was draw a new axis. Maybe go with an x prime axis down to. And we're going to pretend that this is the x-axis. It's not, but I can base everything off of that. So this will take care of my shift. My curve, of course, is going to do the usual, that number, right? But it's going to be down here along this axis instead of up here at the real x-axis. Make sense? All right, the next thing I've got to do is I've got to make sure that the whole curve is done by the time I get to
3 pi over 2.
3 pi over 2, which is right here. So this is where I've got to end. This is where I've got to start, except we're going to start and end here. So I'm going to start at
-2.
0, 0 relative to the x prime axis, and I'm going to end at 0 relative to the x prime axis. So relative to this axis, it actually is -2, but we're looking at this as 0. Then halfway in between the zeros, class, I need another 0. So let's see, halfway in between, oh, it's kind of in the middle of no man's land right here.
Whack.
All right, now here comes the really fun part, because halfway in between here is going to be my 1. So if I were to go over a box and over a box, do you see I'm kind of halfway? Over a box puts me halfway, and I got to split that difference. It'd be like 1/4 of the way, just a little bit past the second box over. And then of course I'm going to have to do the same thing for the negative one, right? Come over a box, come over a box, over a box, over a box, and split that gap. So right about here. And then do your best to connect with a smooth, continuous curve. And again, if you trace lightly, and give yourself the opportunity to erase markings you decide you don't want, that may be ideal. And there's our curve. We notice it shifted down to, and it's squished in. But otherwise, it's your basic sine curve. Okay. Questions on this? Let's do another one. And then we'll kind of open the floor for your questions before the exam. Oh yeah, I like to leave time at the end to customize to, okay, what do we need specific help with? I've gone over everything, what do we need extra practice with? All right, so let's go and do this graph now. F of x is equal to -2 cosine of x plus pi over 3. -2 cosine x plus pi over 3.
I was going to be 15.
Yeah, let me see if I have paper for this one.
All right, I always like to start with my key points, class.
1, 0, -1, 0, 1.
That's because it's cosine.
Yeah.
Then I like to see, is there any inversion, any amplitude changes? Is it inverted, class?
Yes.
Yes, so that's going to change all of these. And the amplitude is 2. So it's going to make all of these -2, and then +2, and then -2. So that takes care of the negative inversion, takes care of the amplitude, takes care of key points. There's only one more number I got to take care of.
Horizontal shift.
Horizontal shift. I'm going to shift,
Pi over 3.
which direction?
What, back?
Backwards, pi over 3. Now, how far is pi over 3?
Less than pi over 2.
It is less than pi over 2.
It's gonna be bad to grab. A box.
About 2.5 boxes.
Like 2 boxes.
2 boxes, right? Pi over 3, remember, is 60 degrees. And remember, 90 is pi over 2, right? 30, 60, 90. Here's 180, which is pi, which is 6 boxes. So basically, one box equals 30 degrees. We just don't use degrees, right? We use actual radian values. But if we want to think 30 degrees, then if you're thinking 60, it's backward 2 boxes. So again, when I set up my f of x axis, just make sure you've got room to go backward a couple boxes. Also make sure you set it tall enough that you can go a little higher and lower with that stretched amplitude there. So there's my f of x axis, x-axis, and there's my pi over 2, pi, 3 pi over 2, 2 pi. Wouldn't hurt, since we are going backward, maybe to label negative pi over 2. Again, backward 3 boxes. Of course, you got our 1, 2, 3, -1, -2, -3. I've got room, -4. And again, my suggestion would be, if you're going to shift, draw a new axis. We're going backward 2 boxes. So right through here, put an f of x prime axis. And so everything's going to start here. All right, so I start here, but I start at what f of x value? -2. And remember, normally we do every 3 boxes to the next quadrantal, right? So I go 3 more boxes, I should be at 0. Then 3 more boxes, I should be at 2. 3 more boxes, 0. And then 3 more boxes, -2. You'll notice we're done 2 boxes before 2 pi. We also started 2 boxes before 0, so it makes sense we'd end a little early since we started a little early. If we wanted to figure, your halves doubled to 1s and -1s. If you wanted to figure your square root of 3 over 2s doubled to square root of 3s and negative square root of 3s. I suppose you could do all of those numbers. You don't have to, as long as you make a careful curve. My suggestion, though, was start where?
At the top.
At the high point, and curve down. And remember, when you come in here, you should almost be coming in sideways at the end, so you could reverse course. So let me retrace over that and try to get a little even better curvature there. All right, and then up here, when I retrace the second side, I'm going to restart on the first side just to help get the same degree of curvature and come in like that. Just to make it look nice and neat. Again, lightly pencil on the exam until you've got it looking the way you want, and maybe trace over darker once you're there. But again, curvature at the bottoms of the curve, and of course good curvature at the top.
Can you like give me some pointers on this? See if this looks good. So.
Curvature at the top looks pretty good, but the straight lines need help. You may want a straight
I don't
edge.
have a straight edge yet.
Yeah, I would come curve it a little bit more there, because again, you'd be reversing course. If you come in like this, you have a really hard time going back up. This had a better curve coming in at the bottom, but it was just that one side there. And then
Yeah.
you may want some extra points, because you're very much straight lining. Just kind of want to, I mean, yeah, even if you at least just got these points to guide you, okay, I've got to hit that point, and I've got to hit that point. This point you weren't too far off, but then you kind of came in way too quickly, so give yourself room to do that curve at the bottom.
Okay.
Okay, would be the biggest thing I would say. The good news is that's minor points, as long as all the other stuff is correct. Yours looks pretty good from what I'm seeing there.
How rare is it for a student to get 100 on a pre-cal exam?
Oh, it's happened a lot. I had a student win the perfect math test award with 7 perfect tests one year. Another student with 4 perfect tests one year also got the...
7's the most you've ever seen?
Who was it?
I don't know if you remember. Well, I can't use last names because it's on YouTube. Her name was Caitlin. She was here for just a few years, played softball. She was my PE assistant one year, in fact. You might remember
She
her.
was homeschooled for some of it, wasn't she?
No, different Caitlin. That was a different Caitlin. We had 3 Caitlins one year. But anyway, the Caitlin that you're remembering, she was the 7 perfect pre-cal test, and she took it as a junior.
How? She was that smart?
She came in with advanced math credits early, so she was ready for pre-cal her junior year. So she took that junior year and then physics senior year. But yeah, so 7 perfect pre-cal as a junior.
So she
was really smart. She was 90th percentile in math in the country on her SAT. So
she didn't have a math senior year?
she did not.
So she had like a lot of study halls then.
She was my PE assistant. I kept her busy. All right, questions on this? All right, we've got about 10-15 minutes with any specific questions you might have. Obviously, if you're watching on YouTube, sorry, you're going to have to send in those questions via email. The students in here have some time. Let me again run through topics. Solving right triangles. Do we feel confident with that, or do we want some more practice? All good? I don't mind practicing.
Solving right triangles.
Solving right triangles, meaning I give you 3 things, you find the 3 other things, like we practiced at the end of the last lesson.
That's the arctangents, they'll do that, right?
Yeah, where you're using
You do
trig
one.
ratios.
You do one.
Let's do one. All right. And again, this is something we are doing in physics as well later today, right on your physics exam. So knowing how to solve right triangles is helpful for that as well. Always good. So let's suppose we've got a right triangle, and we'll name it jet, and we've got a right angle.
The jets are trash.
At E, their jets are trash. And you know what's got to be? No, I know. What's his name had a bad game yesterday for the Panthers. Sam Darnold.
Sam Darnold, yeah.
But until that yesterday, he'd been doing really good. I'm like, that's really got to take the Jets off. Anyway, so
really
right
gotta take him off
E.
if the Jets ruined them.
And we've got EJ. Let's just say is I don't know. Let's say 74 inches, and let's say
I think it's about right, isn't it?
It is. Let's say that JT is
JT Daniels.
Yeah. That seems better.
I don't know. Well, he's the one who's playing anyway. Let's say JT is
55 inches?
No, it's got to be more because EJ looks kind of small compared to JT. So
Doesn't
JT's
so
got to be
bad.
like 80 inches. We're making up stuff here.
He's like 7 foot tall.
And we want to find angle J, angle T, and of course the missing side is ET. All right, add your seats.
No.
And the Jags are so bad. I really thought the Jags had a chance to do something with, they had an improved roster, but they're still trying to build cohesion.
Yeah, they're still garbage.
Cohesion.
They're literally hot dog water.
Hot dog water.
That's the worst. I can't stand boiled hot dogs.
Can't even. They're disgusting.
Grilled, gotta be grilled.
Exactly.
Actually, I did air fried one time because I was desperate.
Was it good?
It was bearable. But I don't know. And beef hot dogs too, by the way. None of that pork and turkey and chicken waste.
Right.
I want Angus beef. I know it's the low end of the Angus beef, but I want pure Angus
You
beef
want
hot
100%
dog.
beef? I want to know what's in my food.
Okay.
Yes. Sometimes they don't care though. Like McDonald's.
I'm gonna say you come with McDonald's or is that Chick-fil-A? It's Chick-fil-A you come with.
Yeah, everyone at that store knows me. Everyone has memorized my order.
That's your
Which one do you
covers.
guys there? Midland?
The one right by here.
Oh, Manchester.
Exactly.
Anyway, working. Like I always say, you can't lose some, you lose some.
Yep.
What's the first thing we should find, class?
The other side.
Let's go get the other side using.
There.
How many sig figs are we allowed in our insert?
Two.
Only 2, unfortunately. So, and this is not drawn to scale at all. Like this is ET is probably going to come out really small. That's my guess anyway.
31.
34. 30.4.
No, it's not.
Yeah, 30.397, blah blah blah. Rounded only 2 sig figs though.
30.
30 point inches.
It's not 31.
So clearly, no, 30.397.
I was thinking of 9.
Yeah. All right, so that takes care of ET. But we're not going to use that number in our calculations, because what if we screwed up, right? So when I go to find, for instance, angle J, what should I do, Ethan?
We already had the two sides, so we can do adjacent over hypotenuse, which is cosine.
Cosine. So we know that the cosine of the angle at J is equal to adjacent 74 over hypotenuse 80. So that means that the cosine of J is like 0.925. But how do I find J?
Would you?
What do I need to find angles, class? Arc functions. So we'll take the arc cosine now of the 0.925.
Kind of curious who would be the 0.25.
And what do we get for angle J?
22.
22 degrees. You got it now?
Yeah.
All right, so Ethan, what do we do to find angle T?
I found T first.
That's
Over.
Sine.
So we'll say the sine of angle T is equal to opposite over hypotenuse, then what?
Arc sine.
Take the arc sine of 74/80ths. And we get
67, 68, 68 degrees.
rounded 68 degrees. All right, do you feel like we got it now, or do we need to do one more?
Yeah.
You got it? All right, any other questions? Right triangles. I think we could all stand to get a little bit more practice with the line diagrams on the unit circle. See if we've got them down yet.
I just studied this. I should do great.
All right, so
Chris, do all of them.
You fucking me.
we've got a circle here, radius 1.
Can I do all of them?
Let's see. All of the circle just looks bad. This quadrant looks pretty close to an actual circular curve. So let's suppose we've got.
It's better to circle than I can go with my arthritis hand.
All correct.
You senior citizen, you.
I don't like the way this goes.
All right, so let's go with a Z, Y, X, W, V,
I looked
U,
down,
T.
stay for a second.
All right, but the nice thing is it's the same lines whether it's up or down, right? So Which trig function is represented by line UZ? Line UZ.
That's gonna be your,
Tangent.
Cosine.
Cosecant.
Tangent.
Secant.
It's throwing all of us off.
Easy. All right, this is the secant line because it meets up with line UX, which is the
Cotangent.
Tangent.
tangent. Okay, so UX is the tangent, UZ is the secant. So we need to remember that secant and tangent go together. Okay, and that goes outside. Tangent, remember, is the one that comes off the end of the x-axis. Okay, what is represented by line WY?
So,
Sine. The up and down, because again, this is the line forming the little inside triangle. And so the vertical line, whether it's up or whether it's down, doesn't matter. That's the sine line, and going with it is YZ,
cosine.
which is the cosine. Okay, so sine and cosine go together. There's cosine, there's sine.
I noted this pattern. Noticed that pattern when I was studying it.
All right, and then what about TV?
Cotangent.
That's cotangent. Remember, coming off the x-axis, up or down is tangent. Coming off the y-axis, either direction, is the cotangent. And then going with the cotangent is VZ.
Cosecant.
Horizon? Cosecant. Okay, so VZ goes with it. So cosecant and cotangent go together. Notice secant tangent, cosecant, cotangent. They're 90 degrees off of where the secant and tangents are. And then sine and cosine just go together because they're cool. They're the big two. All right,
Big two.
questions on this? It's like, well, it used to be like Georgia and Alabama, and now it's like Georgia and
Iowa.
we don't even know. Iowa, no, I refuse to put Iowa in that category.
Iowa's so
Like I
bad.
think if Notre Dame played Georgia, I know we get killed. I think if Notre Dame played Bama, I think we get killed. I think if Notre Dame plays Iowa, I think we have a chance. Like,
Really?
and we're not that great. I think we have a chance to beat Iowa if we play Iowa.
I don't
And
think that's
Tennessee.
gonna happen.
I don't know that we would beat them, but I think we have a chance of beating them. Whereas
What's Notre Dame's record?
we're 5-1. Yeah, we just lost to Cincy because we played stupid and everybody's
Because
hurt.
Cincy's a better team than you.
Maybe they played a little bit better that day. They didn't really look that good though. Anyway,
Cincinnati is such a good team. I may become a Cincinnati fan.
why not? Go Bearcats.
Yeah,
Go
All right.
Bearcats.
They need somebody to cheer for. Actually, no, they had plenty of fans in the stands. It looked almost as bad as when Georgia came. Remember when Georgia came to Notre Dame? Like everybody's wearing red in the stands. I'm like, what is this? Yeah, Cincinnati had
Why
like
was there
half
so
the
many
stadium in
Georgia fans
red. I don't know. That's annoying. Notre
Yeah,
Dame fans like,
imagine
ooh.
Texas A&M. The whole
Yeah,
stadium
the whole
was
stadium.
Texas A&M.
Right, that's what it's
There
supposed
was
to
no
be. That's
Alabama
called
fans.
home field advantage. That's what's supposed to happen. Is all your own
That was
fans
home
buy
field-
all the
home
tickets.
field
Were you
advantage,
mad when
alright.
you saw all the Georgia fans?
Yes.
Yeah.
Like they'd be like, because they know Georgia fans will pay $500 for that ticket because it's a bucket list item. That's the hard part about being a Notre Dame fan. Everyone's like, the bucket list is go to Notre Dame. So if you're playing a team that doesn't normally come, like USC comes, USC fans don't fill a stadium.
Yeah,
because
Cole-
USC plays this every year.
Cole Hammock went to that game
Yeah.
with Georgia and Notre Dame. And he was there at the Notre Dame.
Last name.
He's a Georgia fan.
Anyway, all right. What about stuff on the review sheet? Stuff on the review sheet. We got about 5 minutes left. Anything on the review sheet? Like, ooh, do we practice another one of these?
You just did good.
Yeah, if I would have done it, I would have got everything right.
All right. So no questions on the review sheet. What about graphing? Do we need more practice with the graphs?
Question.
Yes.
It's not practice, but I think I remember saying to you when we were doing graphing that if we did the graph on the test, we had to label like alphabets and sort of
Right. Yeah. Put the
line.
increments, label the axes,
Yeah,
arrowheads, all that
it
stuff.
would be points off if we don't do all
Right.
that.
Right.
I never
Always.
take geometry.
It's been a while. Algebra 2 is when the last time we did all that graphing.
Yeah,
So
but
yeah.
I remember that. So
Yes, you
that's
do,
why I wanted
yes.
to double check to see.
Yeah, that was wise of you. See, there's a reason she makes things. All right, questions.
That's what I'm saying.
All right, any other questions? Anything else we need more practice with? Do we feel good with the graphing? Again, remember on the graphing, plus or minus v is a separate detached term. That's your vertical shift. Plus minus a, your amplitude is going to be multiplied by either sine or cosine. Then we're going to have some value being multiplied, that's your period. And next minus plus h, if it's added or subtracted to the x, that's horizontal shift. Multiplied by the x's period, multiplied by the sine amplitude, separate term from everything vertical shift. So you might want to write that on your review sheet paper. Any other questions? Last call for questions.
Maybe could we go over the cofunction of a acute angle? thing?
Yeah. So if I gave you, for instance, the, let's do one with radians. We didn't do one with radians. Let's do one with
Jamie,
the,
I didn't know that would happen.
cotangent of negative 7 pi over 3. Alright, so what do we have to do here, class?
Do you have to minus 6 pi over 3?
Minus 6 pi over 3?
Wait, add.
Let's add 6 pi over 3.
Yeah.
Are you okay?
Yeah.
And if I add 6 pi over 3, that gets us to, oh, we're still negative, so what do you have to do again?
Do it again.
Add another 6 pi over 3, Jamie, to get?
5 pi over 3.
You better let her do all this.
Oh yeah, it's her problem. Alright, and now, Jamie, we can finally ask ourselves, what
Quadrant.
quadrant are we in? And we're in quadrant
4?
4, because it's nearly 2 pi's, right? It's nearly another 6 pi over 3. Reference angle?
Pi over 3.
Pi over 3. So we could rewrite this as the cotangent of pi over 3. Now again, if we were finding the value, we'd say cotangent of 60 is what? But we're just rewriting. And quadrant 4 cotangents,
Negative.
negative. Then to convert to the co-function, what do we do with the SIGN?
Keep it.
What do we do with the cotangent?
It's tangent.
Tangent. And then for the angle, we would subtract from
Pi over 2.
pi over 2, or 90 degrees if it's in degrees. And when you subtract pi over 3 from pi over 2, get a common denominator of
6.
6. So make that 3 pi over 6 minus 2 pi over 6 gives.
Pi over 6.
And there we go. All right. Any other questions? We have 2 minutes. Any other questions? All right. We'll do well on the exam tomorrow. Study as needed. Go back, look through notes as needed. At least make sure you know your unit circle lines. And we'll be good. All right.